Hello everyone, this is Everyday Leetcode and my name is Tikitoshi. Today we are going to solve another interesting problem, that is print in order. We are going and jumping to concurrency, but let me just tell you that this is a concurrency problem. This is a different problem than the normal problems that we do. So if you're not aware of conditional variables, if you're not aware of mutexes, semaphores, all these important terms, then probably you might really want to understand the theory first and then come back. But even if you do not have that much clue, I will be trying my best to give you a better understanding of that. So let's just understand this problem. So you have a class and class called as foo, and there are three methods in it: the first, second, and the third method. The first method will simply print first, second will simply print second, the third will simply print third. Now the same instance of foo will be passed to three different threads. That means you have thread A. Okay, that thread A calls function 1, thread B will call function 2, and the thread C will call the function 3. So what we want is these threads should be in synchronization. That means the synchronization I want to achieve here is that I want to call thread 1, then thread 2, and then thread 3. So what, not really actually, but I want to execute, I want to print first, then I want to print second, and then I want to print a third. So definitely the best logic that comes into our mind is keep two mutexes. It's not the correct solution, of course, but let's try to think about it. Keep two mutexes. When you call the first function, you lock your mutex, first mutex. Uh, Initialize the two mutexes, keep both of them locked. Um, Keep both of them locked, and yeah, keep both of these mutexes locked uh, within the first function. I can say m1 is first mutex, m2 is the second mutex. Within the first function, since both of these mutexes are locked anyways, I've initialized them as that way. The constructor has made them lock. I can just print the first as it is, and yeah, I can just print the first and then I can unlock the first mutex. Now the second the second function, the first line, we can write m1 dot lock in the second function. Now when I write m1 dot lock in the second function, the second thread has to wait for the first thing to get executed and for the first m1, that mutex, to be unlocked. When it acquires that mutex, it's at that particular point of time it can go ahead, so it will keep waiting at m1 dot lock. So unless m1 is unlocked, it will keep waiting. It will print the second, it will unlock the second guy, although it has not acquired it. That's the wrong thing over here. The second function did not acquire the mutex 2. M2 dot unlock is not really a good way of achieving things, so that's wrong there. But that is how. And I can start with m2 dot lock in the third, and then I print the third, I unlock that second mutex. So that's how you could have written it. It would have worked in Leetcode, but logically that's not how the solution should go about, because mutexes, always remember, only when you lock a mutex, only when a particular thread who acquires the mutex, that thread can unlock it. Not any other thread can unlock it. So although it's working in the code, but no, that's not how you solve it. So we use conditional variables. So what we do here is, let's walk through this example. Let's say the thread 2 gets executed first. the thread 2 gets executed, the 3 gets executed, and 1 gets executed. I initialize a count variable to 1. I initialize the count variable to 1. Okay, the more I initialize the count variable to 1, 2 is executed. Okay, what I will do is within 2 I will have a conditional variable, and I will say wait. Wait for how much time? Wait, you have to first make a unique log for that. Once you make a unique log, mutex is sent here. Once you make the unique log, wait, as long I'm writing the second, right? I'm writing second as a function. Okay. The moment I acquire this log, I will have to go into the wait state. And what should be the condition of the wait state, right? That's important. I would return count is equal to 2. So I will keep waiting until the count is equal to 2. Since the count is, so what happens is, since if the count is 1 initially, this will return a false. Because this is a false, it will say that I have to wait now. I have to wait until the count becomes equal to 2. So I wait here. Okay, similarly, I can have this particular thing in the third function as well. Okay, this count is equal to 1. That's just initialized. Okay, so I keep waiting. Okay, the moment it becomes 2, I simply print 2, whatever I had to print. The moment it becomes 3, I'll just print 3. But after printing 3, I change the count to 3, right? Similarly, in the first function, what I'll write? I'll first log it, or do I really need to log the mutex? Yeah, I need to acquire the log. Every time I do this, I need to acquire the logs, because that's how it works in concurrent programming. You have to have one log. The person who acquires the log has the resources. First function will print a first. It has to just print first. It does not wait for anybody else, so there's no wait as such here. It will print a first. Now it makes a count is equal to 2. So when the count becomes equal to 2, this gets executed. It will print the 2. The count becomes equal to 3. Now this, where it was waiting, it gets executed. It will print a 3 and it will come out. So this that's what the code is here. I just, of course, oh, I forgot talking about the notify all. So when the count it's gone into the wait state, and now this thread is actually sleeping, so it does not really check anything. When I get the cv.notify all, it means that the first function has been executed. Now all the threads that were sleeping, now they can wake up, and after waking up they can check the condition. If that condition returns a true, you can go ahead. So it just goes into the wait state, returns a true, it goes ahead, it prints the second, count becomes equal to 3. It now notifies everyone that I'm releasing the mutex. Everybody receives that call. Since this conditional variable was on a wait, it checks the count again. If the count is true, this count is true, now it prints third. So that's how the concurrency over here works. It's a very exciting topic. It's a very interesting domain. It's just that this was the most easiest problem in concurrency. But yeah, that's how we'll grow. We'll do one at a time. Yeah, that's it for today. Have a great day.